Hello, this is Richard C. I'm a math tutor here at Wyzant, and we're going to talk about solving an inequality involving negatives. I like this question because the student who wanted an answer to this is also interested in checking his work, which is a wonderful habit to get into. Most of us don't check work very often. So the example that he wants solved is this inequality, negative 2x less than or equal to 16. So they'll just put that up there. And so we're going to solve this. I'm going to change colors to solve it. I'll do it in green. So I'm going to divide both sides by negative 2 because I need to isolate the x. So when I divide by negative 2, I get the exact result that I want. I've isolated x is all by itself. And on the right-hand side, when I divide by negative 2, I get negative 8. So far, so good. If this were an equality, I'd be done, but I'm not done here because whenever you multiply or divide by a negative and you're trying to solve an inequality, you have to change the direction of the inequality. And so if you forget to do this, you're going to come up with the wrong answer. I could have done the very same thing with just a straight less than. Sometimes students ask me about this. Does it matter whether it's less than or equal? I could have had negative 2x strictly less than 16. And then the same thing would happen. I would divide by negative 2. And I would get x greater, greater than, excuse me. I would get x greater than, it's negative. So you can see the answers are almost the same here. One has the equal sign as part of it. It's less than or equal to. Here, there is no equal sign. Now you could, so the same rules, the same steps, and all of that. So now let's talk about checking the answer, which was the student here was very interested in checking the answer, which I think is wonderful, and I want to encourage everybody to take the time to do that. So let's check the answer. The way you would check an answer here is you would just pick a value. You think of the number line here, we've got 0 and negative 8. And if we were to draw the solution on the number line, the solution would look like this, greater than or equal to negative 8. So I can take any value in this region and plug it in and see if it works. So let's take negative 7. So if I took negative 7, I would get negative 2 times negative 7 less than or equal to 16. And then I'd get 14 less than or equal to 16. And so it checks and it works. I could have also taken negative 8 here, you see, because the solution that x has to be greater than or equal to negative 8. So I could have taken negative 8, negative 2 times negative 8 less than or equal to 16, and that would give me 16 is less than or equal to 16. So that checks also. And any other value, I could, let's do one more. We could do 0, negative 2 times 0 is less than or equal to 16. And so 0 is less than or equal to 16. So that checks as well. And so that's the way you would check your work. You could take anything in this region. I prefer to check want an endpoint. If there is an endpoint, I kind of like to use those endpoints. That was this middle example. Back over here on the right, we cannot use -8 because it's strictly greater than -8. So once again, on the number line, here's -8, here's 0, and so this would be strictly greater than -8. So I can't use -8. So for this one, maybe I'd use -7 or maybe -7.9 or 0. Anything in the region, in the solution region will work. So that's an example of how to solve inequalities involving negative values, and more importantly, or maybe just as importantly, how to check your work when you're done. It's always good to know that things worked out the way they should. So that's it for this lesson today. Thank you for listening, and good luck. Bye.